right, welcome back. Now we're going to continue with the next lesson. Lesson 2.2 is called Finding the Nth Term. And we are going to use our inductive reasoning skills to determine some function rules that are going to help me find the value of terms without necessarily having to complete the patterns over and over and over again. Let's take a look at our first example. So finding a function rule. Using inductive reasoning, we can find patterns that create function rules to help us find the nth term. So let's look at our first example of how we're going to use this. So our term is just basically the order of the numbers. So it's always going to be 1, 2, 3, 4, 5, 6, so on and so forth until we get to maybe the nth term. So the n term is what we don't know yet. That's the goal or the end or just some unknown value. Now the value is the corresponding result based upon the term's placement. What's the value? So the first term is 7, the second term is 2, the third term is -3. I can see pretty quickly that my values are decreasing. And they're decreasing at a constant rate of -5. So to get to the next term, I'm subtracting 5 from the previous term. Now that constant difference is the coefficient of our rule. The function rule is like, let's see if I can spell function. The function rule is an expression, a mathematical expression that we use to help us find the value of the nth term. So this constant difference is going to be my coefficient. So I'm going to multiply -5 times n, so times that term placement, and then I'm going to add or subtract some constant value in order to get the value of the number. So in order to find that constant, I need to set up an equation to solve. So let's say, for example, if I know that the value of the first term is 7, I know that -5 times 1 is not equal to 7, but if I can figure out what c is equal to, what that constant being added to it or subtracted to it maybe, then I can create a rule that will work every time. So step 1 is to find the constant difference, which is what we call the coefficient. And the difference can be positive or negative. If the difference is negative, like in the example, your coefficient's negative. If the difference is positive, then your coefficient's positive. Then we want to find the constant value. This is what we know as normal constants. So regardless of what n is, we're always going to add some constant to it. So let's solve this out. We get -5 plus some constant equals 7. So add 5 to each side. And c is equal to 12. So we are using our inductive reasoning to determine that the rule is -5 times n plus 12. And that's supposed to give me some value. Well, let's take a look and make sure that this actually works. So I'm going to choose a random number here. Let's say term 5. So if this rule works, then -5 times n, so in this case 5 because it's the 5th number, plus 12 should equal -13. So -5 times 5 is -25, plus 12 would equal -13, and that was what the value was. So yes, that rule is correct. So using inductive reasoning to find the pattern, then we can make the conjecture or the function rule. Notice here at the bottom it says rules that have a constant difference are linear functions. So if the difference is not constant, meaning -5, -5, -5, if it changed, kind of like the previous lesson's example, then those are a different pattern. And so we will talk more about those later as they come up. Right now, the rules we're dealing with are linear functions. So if you were to graph this, it would form a nice straight line. All right, let's look at the the next slide. All right, if you place 200 points on a line, into how many non-overlapping rays and segments does it divide the line? So now we are wanting to figure out a pattern in order to answer this question. One of the ways we can do this, and probably one of the best ways to do this, is we want to create a table to organize our data. The key to making good conjectures is going to depend on having good data. All right, I'm trying to make this little pen smaller so I can fit all the information I want to. So let's take a look. We have points on a line and we want to know how many non-overlapping rays and segments does it divide the line. So I've got a bunch of different categories going on here. Let's say points that divide the line. Use some shorthand here. That's supposed to be points. There we go. And how many non-overlapping rays and let's say how many non-overlapping segments. So you can see why your terminology, your vocabulary is going to be important here. And then we want to know the total, because we're figuring out the total of it. So we'll have some addition here. Now let's draw a picture to kind of help us figure out what's going on first. So the first number I can start off with is 1 point. So if I have a line, and I put 1 point on it, how many rays is that going to make? Well, I have a ray going to the left, and I have 1 ray going to the right, so it's giving me 2 rays. Now, overlapping or non-overlapping segments, well, I don't have any segments because I don't have 2 points. So, no segments. So, rays plus segments, I have a total of 2 altogether. So then, let's say, okay, what happens when I add 2 points? Well now, again, non-overlapping, that's the key here. So I have a ray going this direction, and I have a ray going this direction. But if I say here to here, technically that's a different ray because it has a different endpoint, but notice that it overlaps with the second ray we drew. It's overlapping with the one that's above it. So we don't want to count that one. So I only have the rays that are coming from the very 2 endpoints. So still just 2 overlapping rays. But notice now, since I have 2 points, I have a line segment here in the middle. So I have 1 line segment. So 3 geometric things all together. And I clean that part up a little bit. Hopefully, won't erase too much. All right, a little bit better. Get back to our pen. Now, the next time, let's see what happens when we have 3 points. So draw our line, put 3 points on here, and figure out. Well, again, the 2 endpoints are making the 2 rays. I can't include anything in the middle because if I do that, I'm going to have overlap. But I have this endpoint and this endpoint, that makes a line segment, and this endpoint and this point makes this line segment. I don't want to go from here to here because that's going to give me an overlapping segment because it's going to overlap what's already existing. So I have 2 segments altogether. I have 4. Change the color a bit to kind of help us with the next picture so I don't have to keep erasing. Let's go in green. Alright, so let's say we're going to have 4 points. I'm going to add a point here. It doesn't really matter where I add it, I'm just putting it there in the section. So again, the 2 rays are at the end. Notice that's pretty consistent there. And then I have 1 segment, 2 segments, 3 segments. Altogether, I have 5. I could add a 5th point. So I still have the 2 rays, and then 1 segment, 2 segments, 3 segments, 4 segments. Altogether, I have 6. Now, we want to know what happens if we place 200 points on a line. Well, I don't want to go through that process of actually putting 200 points on a line and counting everything. So let's find a rule that we can use for the nth term. For non-overlapping rays, only the two endpoints are creating that non-overlapping ray. So no matter how many points on the line I only have two non-overlapping rays. Now for non-overlapping segments, notice that it's one less than whatever the term number is. So 1 was less than 2, 2 was less than 3, 3 was less than 4. So whatever the term is, minus 1 gives me the rule. And then notice that the total was 1 more than whatever the term was. So 5 was 1 more than 4. 4 was 1 more than 3. So the total is n plus 1. Now we want to know how many total non-overlapping rays and segments does it divide the line into. So if I put 200 in for n, add 1, I'm going to get 200 rays and segments. If I wanted to know more specifically, I could say 2 rays and 199 non-overlapping segments. And that's how we can use the inductive reasoning to create the rule in order to solve the problem, so that we don't have to go through the process of drawing out an extensive picture. We can just draw out these smaller steps to help us go forward. So word problems that you have: step 1, draw a picture to kind of visualize what's going on first, then organize your data. Make a good table to put your data into categories and see if you can notice any patterns, and go from there to solve your problem.